Hello everyone, this is Rashil Aishram from Manipur University. Today I am going to present on the topic structural and optical parameter of solder-derived barium strontium titanate thin film. Barium strontium titanate is one of the most interesting ferroelectric materials because of its high dielectric constant, low dielectric loss, good chemical stability, and chemical dependent QA temperature. Barium strontium titanate are widely used as voltage tunable capacitors, resistors, tunable filters because of its high sensitivity to electric fields, and it also has its optical application in solar cells, IR detectors, and in optical memory devices. In the present work, barium strontium titanate thin film was prepared by solder method on a chronic glass substrate using a programmable spin coater. Later, the structural analysis of the fabricated thin film was done by using X-ray diffractometer. The optical parameters such as optical band gauge, refractive index, absorption coefficient, dielectric functions were analyzed from the UV visible absorption data taken from Perkin-Elmer UV visible spectrophotometer. Here is the systematic diagram for the fabrication of barium strontium titanate thin film. First, stoichiometric amount of barium 2-ethylhexanoate and strontium 2-ethylhexanoate was taken separately in ethanol and dissolved in reflux conditions. Later, the solutions were mixed together to form barium and strontium solution. In this solution, we add 6 ml of titanium for isopropoxide and reflux for 1 hour to form barium strontium titanate solution. Later, we add 0.5 acetyl acetone and 0.5 bromamide to control pyrolysis, and the solution is later filtered using a nanofiber filter paper to form the stock solution. This is used for the fabrication of the thin film in a spin coater. The fabricated thin film is later dried at around 300 degrees Celsius to form amorphous thin film, which later form crystalline thin film after annealing at 500 degrees Celsius. The structural analysis of the prepared sample is done from the X-ray diffraction pattern. The X-ray diffraction pattern of the BST thin film is given in figure number 2. All the peaks are indexed as compared to ICDT card number given here. The crystallite size of the sample was calculated by using the well-known device error formula. In order to quantify the XRD data, we all detected coefficient of some of the prominent peaks are also calculated. Here we have taken the plane along 110, 111, and 200 plane. And in order to understand the strain-induced peak broadening of full wide half maximum of the XRD data, the Williamson-Holdsworth analysis was also performed. Table number 1 presents the structural parameter of the fabricated barium strontium titanate thin film. From the analysis of XRD data, it is revealed that the synthesized barium strontium titanate thin film has cubical structures belonging to the space group EM, 3M with preferred orientation along 110 plane. From the texture coefficient, we can also see the domination of 110 plane over other available lattice planes. Microstrain calculated from the Williamson-Holdsworth is about 0.0523, and the crystallite size calculated using device error formula is around 37.4 nanometers, and the crystallite size calculated by using the Williamson-Holdsworth is around 5.66 nanometers. The optical analysis of the synthesized sample is done by analyzing the absorption data, UV visible absorption data, and the optical thickness of the fabricated thin film is found to be about 939.3 nanometers. The variation of transmission percentage as a function of frequency is shown in figure number 4. From this optical transmission spectra, we can see interference fringes and high transparency up to 80% at higher wavelength. The optical band gap of the prepared sample is also calculated by using the Tau's relation and the value is found to be around 3.52 electrovolts. The refractive index of the prepared sample is calculated by using Swinburne envelope method, and the variation of refractive index with function of wavelength is given in figure number 6. From this plot, we can see that the refractive index decreases with increase in wavelength, and the average refractive index of the sample is found to be around 1.515. And the complex dielectric constant is also calculated using Kramer's and Cronin relation, and the real part and the imaginary part of the complex dielectric constant as a function of wavelength is plotted in figure number 7. From this plot, we can see that the imaginary part decreases when the real part increases. The maximum value of the real part of dielectric constant is found near 650 nanometer. In table number 2, it presents the comparison of refractive index of the present work with the previously published values of refractive index of the BSc thin film. From the tau plot, we have already seen the deviation of the curve from the linearly fitted graph, and this deviation is defined by another optical parameter called the Erbeck energy. In order to quantify the Erbeck energy, we calculate near its absorptive ratio near, and the calculated value of near is found to be around 0.48, which is quite small, and it suggests that the prepared sample has less defect. If there were more defects, then the value of near will found near 1, and the Erbeck energy is calculated by using the relation given here. Here, alpha is the absorption coefficient, alpha naught is a constant, E is the energy, and EU is the Erbeck energy. And by plotting a curve between ln alpha and the photon energy h mu, we find a curve, and by fitting a linear fit and taking the inverse of its slope, we can calculate the Erbeck energy, and the calculated value of the Erbeck energy is found to be 0.22 electrovolt. So in conclusion, we can say that barium strontium titanate thin film with thickness 939.9 nanometer was fabricated successfully on a Corning glass substrate by using solvent method and using a programmable spin coater. The structural and the optical parameter of the fabricated thin film was analyzed using X-ray, XRD, and UV visible spectroscopy. Optical parameters such as refractive index, extinction coefficient, absorption coefficient, real and imaginary part of the dielectric constant are also calculated. The calculated crystallite size of the thin film is found to be around 37.45 nanometer. The band gap and the average refractive index of the prepared sample is found to be 3.52 electrovolt and 1.515 respectively. The fabricated thin film also shows high transparency at higher wavelength, suggesting its potential application in optoelectronic devices. So here is the end of my presentation. Thank you.